Today's video here is a nice problem which is coming from Dutch Mathematics Olympiad in 1985 or Netherlands, okay, Olympiad. So for some p, we have this following equation. We have the equation is coming on the form of the polynomial. So here is the following statement. We have x cubed plus p is multiplied by x squared plus 3x minus 10 equals 0, okay. This polynomial has three real solutions. A, B, C satisfied this following condition. So we have c minus b equals b minus a, which is strictly superior than 0. The question is determine a, b, c and p. Indeed, this is very nice and ordinary equation. Now let's go through this one. We have this following equation. I'm going to put it on the form of the function. So f of x, which equals x cubed plus px squared plus 3x minus 10. Since we have a, b, and c are the roots of this polynomial, so which means this one is going to be written on the form of product, which is x minus a factor x minus b factor x minus c entire, which is equals to 0. Okay. So starting with these two first terms, I get here f of x equals x squared as a first term minus xb as a second term minus ex plus eb. We finish with first product. Then this bit is going to be multiplied by this one, which is x minus c equals 0. Okay. Then continue distributing this one. I get x cubed as a highest degree of this one is multiplied by c is multiplied by x squared. Then I'm coming to the second term. I get here minus bx squared, then plus bcx, which this one is multiplied by this one. Then coming to the third term, I get here minus ax squared plus acx. Then coming to the last term, which is plus ebx minus ebc. Entire thing equals 0. I'm going to collect the coefficient, so I get it here x cubed. So I get here I get here minus c minus b and minus a are the coefficient of the x squared power. Okay, so which is I get minus c minus a plus b plus c is multiplied by x squared like this, then plus ab plus ac plus bc is multiplied by x plus the last term, which is minus abc equals 0. Okay, if I'm going to match term by term, so we have this one equals to p. So I'm going to make the equation system here. I get this term, which is a plus b plus c equals minus p. Okay, then moving on to this one, I get here ab plus ac plus bc equals to 3. Then lastly I get abc equals 10. Okay, because we have minus sign here. Then in order to solve this equation, I'm going to work on this condition first. So if you take a look at the first equation, I get the sum of these terms equals minus p. So I'm going to write this one on this form by moving over this minus a to the left and moving over the b to the right. I get here I have c minus b equals b minus a. Okay, by using this condition. Then I'm going to move over this minus b to the right and minus a to the left. I get the following. I get a plus c equals 2 times b. I'm going to use this fact and replace it into this equation. Okay, so I get here the following. I get a plus c equals 2b plus this b, which is 3b equals minus p. Okay, then if you take a look at this one, by using the same condition for the second equation, so I'm going to use this term and make it as a common factor and make b as a common factor. So I will have here, then multiply both sides by b. Okay, again I get the following. I get a new equation system here. 3b equals always minus b. Then this one, by multiplying this 2b with this b, it becomes 2b squared. Multiply by this b, it becomes 2b cubed. Okay? Plus this term is multiplied by this term, which is ACB, equals 3b. We know this ACB equals 10. Okay? I'm going to replace this one with 10. A nice equation in terms of b here. So by moving over this 3b to the left, I get here 2b cubed minus 3b plus number 10 equals 0. Okay? I have ended with a nice expression in terms of b. Okay? Now I'm going to solve this equation for b. Okay? So always we have this condition also. So in order to solve this equation, I'm going to guess to find the root of the. In order to solve this equation, I'm going to guess. So in order to solve this equation, I'm going to guess to find the first root of this equation. Okay. So I'm going to put this one as a polynomial. So let's set g of b equals 2b cubed minus 3b plus 10. Okay? Let's put it as a function here, as a polynomial. Let's set f equals 2t cubed minus 3t plus number 10. Okay? So if I'm going to check the root of this one, like g minus 2 is giving us 0, because replacing 2 with minus 2, I get here minus 2 cubed, which is minus 8, is multiplied by 2, which is minus 16. Minus 16 I got here plus 6, which is minus 10. Minus 10 plus 10, which equals to 0. Okay? Which means minus 2 is a root of this function. So now I'm going to factor out that one by using these roots. So I will have 2b cubed minus 3b plus 10 equals b plus 2. Factor. I'm going to put the first term as 2b squared plus something plus the last term, which is 5. Why is 2b squared here and number 5 here? Because when you distribute this one by this one, is given as number 2 as a coefficient. Okay? So which means I have to put number 2 here, number 5, because the last term, when you distribute the last term, you get 2 is multiplied by 5, which is 10. So we need just to figure out this one by guessing. And there is another special thing here. If you take a look here, this one, there is a nice trick to find the mirror term. Okay? The mirror term, we must have minus sign here. Why that? Because when you distribute this number 2 by the first term, you get 4b squared. But we don't have 4b squared here, which means 4b squared was cancelled out by this term. This term must be the same but with minus sign, which is minus 4b, to get the equation of the second order in this order. Okay? Now we have done with this one, equals 0. Sometimes you may get this term positive. You get this positive, that means we have no roots for this one. So we don't have to worry about this one. So we are going to move on to this one to get the root of this one. Okay? I'm not going to use the delta here. I'm going to factor out this one. So I get here 2b squared minus 4b squared minus 4b plus number 5. Okay? So I'm going to use the trick here. I'm going to write this one as b squared minus 4b plus number 4 here plus b square plus number 1 here. Okay, I just split the terms. Okay, the first term was split by two terms, which is b square plus b square. The middle term stays the same. The last term, it was number 4 plus number 1, like this. This is a quadratic polynomial expression, which is one is going to be the same as b minus 2 quinary square. If you distribute this one, you get b square minus 4b plus number 4 plus b square plus number 1. So this one is strictly superior than 0. Okay, so which means we have no roots of this one, so all the root of this one goes towards this one. So which means I get b equals minus 2. So here is the solution. Here is the first solution. B equals minus 2, which means I'm going to determine p now. So I get p equals minus 3 is multiplied by b, which is going to replace with minus 2 here, which equals number 6. Okay, now I get two values. I get b equals 6, I get b equals minus 2. We need to determine a and c. Okay, let's take these two facts at the top and continue solving our equation. This is very clear. I'm going to determine this one because I know the value of b. So I get the sum of a plus c equals to b, which equals 2 is multiplied by minus 2, which is minus 4. Okay, I'm going to take the advantage of this one. So we know this value of a plus c equals minus 4. We know this value of b equals minus 2. So I'm going to determine this product AC. So I get here minus 4 is multiplied by minus 2 plus AC equals 3. Okay, so equivalent, I get here minus 4 is multiplied by minus 2, which is 8, plus AC equals 3. Equivalent, the product AC equals is minus 5. Okay, so I know the product is equals minus 5. I know the sum equals minus 4. So I'm going to put this one on the form of the equation system. I get here A plus C equals minus 4. I get AC equals minus 5. Okay, so I'm simply going to replace one of these values into the other one. Okay, so I get here C equals minus 4 minus A. Taking this value and insert it into the second equation. So I get here A is multiplied by minus 4 minus A equals minus 5. Equivalent, I get minus 4A minus A squared equals minus 5. Taking these two terms to the right, I get the following. I get A squared plus 4A minus 5 equals 0. Okay, I'm not going to use here delta. I'm going to use another trick in order to get this one solved quickly. Okay, so what is this? This one is the same as A plus 2 quinary square. If we try to expand this one out, I get E squared as a first term plus 4A as a middle term, which is good, but plus number 4, we don't have the plus 4 here. We should subtract minus number 4 from this one. Minus 4 minus 5, which is the original one, equals 0. Equivalent, A plus 2 quinary square. Minus 4 minus 5 is minus 9. I'm going to move over this minus 9 to the right. I get here 9, which is 3 square. Okay, I'm going to apply the square root on both sides. I get here the following solution. I get A plus 2 equals plus or minus 3. Okay, this one is giving us A plus 2 equals 3, and or A plus 2 equals minus 3. In the other word, I get A equals 1 because 3 minus 2, or A equals minus 3 minus 2, which is minus 5. I get two solutions. Okay, then I'm going to find C. Since we have this expression, I'm going to take the advantage of this one by replacing A into this one to find C. Okay, so here is simple. Here is very simple. C is going to be minus 4 minus number 1, which is minus 5, or C is going to be minus 4 minus 5, which is plus 5, which is number 1. Okay, so I get 2 values of A and 2 values of C. So since we have this condition, C minus B equals B minus A, which is strictly superior than 0, we are going to look which the solution, we are going to look which appropriate solution is satisfy this condition. So C1 doesn't work here because C1 is negative minus 5, which is less than 0, because minus 5 plus number 2 here is given as minus 2, which is not working here. Okay, so we are going to move on to the positive solution, which is C2, which is equal to 1, because 1 minus minus 2 is given as 3. 3 is positive. Okay, so C1, so C2 minus B equals 1 plus 2. Okay, which is the right solution. Look, we are going to look for the second one, B minus A. If we are going to look for the positive one, it's not going to work here, which is contradict our condition. Okay, so which means A equals minus 5 as a value. That's the right one. Okay, because minus 2 minus minus 5 is given as number 3 here, which is strictly superior than 0, which equals to this one as well. Okay, so which means this one I get B minus A 1. Okay, is equals also minus 2 plus 5, which equals 3, which is strictly superior than 0. So we have C2 and E1. That's the only solution that we have to satisfy this condition. So which means I'm going to put this one down here. E1 equals minus 5 and B equals minus 2 and C2 equals number 1 with B equals 6. That's the only solution satisfy this equation. Okay, so I have ended this video. Just consider subscribe and like. Thank you for watching. I will see you next video. Bye.